Good morning. This is Dr. Jingbo Louise Liu from Texas A&M University, Kingsville. I'm the instructor for organic chemistry. So today I'm going to discussing isomeric alkane, the nomenclature of alkane and cycloalkane, and some related chemical physical properties of these different organic compounds, hydrocarbon-based organic compounds. The first topic is related to the isomeric alkane. The first example is related to the butane. For this butane, totally you have 4 carbons. These 4 different carbons, you can have different connectivities of the carbon atoms. Therefore, you are going to form isomers. As we mentioned before, your isomers can be, generally speaking, distinguished into 2 major groups. One group is called the constitutional isomer. These constitutional isomers are created because of the different connectivity. The second type of isomer is called the stereoisomer. The stereoisomer can be generated because of the spatial arrangement, which are different, even though the connectivity of different atoms are the same. So the constitutional isomers is what we are going to learn for today. Again, for this butane, 4 carbons, you can write it down this way: carbon 1, 2, 3, 4, all connected to each other in a branch way, in a straight line. And the second part, so you write it down: carbon 1, 2, 3, and the 4th carbon is going to be connected to the number 2. So you are going to result in 2 different structures. One is called the normal butane, second one called the isobutane. Therefore, you have 2 different isomers. So again, this type of isomers, they are called constitutional isomers due to the different atomic connectivities. These isomers, they have different physical properties. They have the same chemical formula, C4H10, but the connectivity are different. Therefore, the bond line structure also going to be different. The isomers again have different physical properties. In this butane, so normal or isobutanes, they both have a carbon hybridization, which is sp3. The bonding also sigma bond, and you also have a carbon bonded with other 3 hydrogens, except the carbon 2 and the carbon 3. Carbon 1, carbon 4 bonded with 3 other hydrogens, and the carbon 2, carbon 3 bonded with 2 more other hydrogens. About the boiling point and melting point, for normal butane and isobutane, you can see they are different. The normal butane, generally speaking, has a higher boiling and melting point. The reason is the normal butane has a stronger London dispersion, which is one of the intermolecular forces. And then if you go to higher N alkane, if you increase the number of N in your alkane, your general formula for your alkane normally is a CN H2N plus 2, but most of the cases for the straight chain alkane, we are going to write it down as a CH3 parenthesis, CH2 close parenthesis, N, CH3. CH3, 2 N's, you write it down. In between, you are going to increase by CH2 groups. CH2 units is going to be increased. If you have this N, which is 3, so you have CH3, CH2, 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 and then CH3. So this molecule, if you put them together, all the carbons connected to each other in a straight line. In this case, you have your normal pentane, 5 carbons. Its bond line structure will be 1, 2, 3, 4, 5 carbons. So that's how you are going to draw it. If this N is 4, so you have CH3, 4 of the carbon CH2 unit groups, and then you have CH3. So you got 1, 2, 3, 4, 5, 6 carbon. This alkane, you call it normal hexane. So again, your formula can be written down in different ways. You can, for the pentane, you can write it down C3H23CH3. For your pentane, hexane, you have 4 CH2 groups, CH2 units are going to be existing in this molecule. You write it down the condensed structure or abbreviated structure as CH3, CH2, 4 of them, and then CH3. That's essentially how you are going to express your alkane with a larger number of N. So let's take a look at the pentane, C5H12. How many different connections can be resulted from this C5H12? Let's take a look. You put all the 5 carbons, carbon 1, 2, 3, 4, 5, directly connected to each other. You call it normal butane. If the 5th carbon, you can connect it to the 2nd carbon. You have carbon 1, 2, 3, 4 connected to each other. 1, 2, 3, 4. And then the 5th carbon connected to the 2nd carbon. So in this case, you call it isopentane. So imagine you have carbon 1, 2, 3, and then number 4, number 5 carbon both connected to the 2nd carbon. In this case, you call it neopentane or terbutyl actually. So neopentane. So you have 3 different isomers. All of these 3 different isomers, they are representing your C5H5 pentane. So again, depends on the different numbers, the IUPAC system can have that for that particular structure can have different isomers. So how do we name the unbranched alkane? Based on IUPAC nomenclature, so International Union of Pure and Applied Chemistry. So these names, first of all, you are going to find the number of carbon in the parent. So if you have 1 carbon, you call it methane. 2 carbon ethane, 3 propane, and then butane, pentane, hexane, heptane, octane, nonane, decane. That's for the first 10 carbons. If they are the straight line, non-branched, that's the parent alkane. If you have 11, you call it andecane. 12, dodecane. 13, tridecane, tetradecane, pentadecane, etc., etc. For 20, you call it icosane. And 21, hinocosane, etc., etc. So this table 2.2 essentially showed you the parent name of the unbranched alkane. They will be very useful for your future nomenclature. So how we are going to apply the IUPAC rules to name the different hexane, different alkane. For example, the hexane. Rule number 1. So you are going to find the longest continuous carbon chain and name it as the IUPAC name based on the table, above table I showed you. So this parent will be your name for that related alkane. And then you are going to identify the substituents on the chain. For example, I have carbon 1, 2, 3, 4, 5. If you have 5 longest continuous carbon chain, you name it as pentane. In the second carbon, you have 1 substituent. This substituent will be named based on 2 parts. Number 1, you need to know where is the locant. The locant must have the smallest number. And then this group will be named from the parent. If you have 1 carbon, you call it methane. You change this methane to methyl. This methane change to methyl. This group located in the number 2 carbon. Therefore, you put 2 in front of the name. between the number 2 at the locant and the word methyl, you use a hyphen to separate it. Hyphen is used to separate the numerical locant and the letter of the nomenclature. And then for the other more branched alkane, you are going to use the same rule. So first of all, find the longest carbon-carbon chain, name it as your parent. If you have two different substituents, if the two substituents are the same, you call the di, three, you call tri, tetra, etc., etc. For this first compound on your left-hand side, you have butane, that's the parent. In the second carbon, you have one methyl, two methyls. Therefore, you call 2,2-dimethylbutane. Between 2 and 2, you use a comma to separate two numbers, and then followed by a dash. The right-hand side, this compound, you also have 4 continuous longest carbon chain, you also call the butane. Number 2, number 3, you have 2 more methyl groups. Therefore, you call 2,3-dimethylbutane. Between 2 and 3, again, you are going to use a comma to separate them. For the alkyl groups, how do you name them? Again, the alkyl groups, they are substituents which are derived from your parent alkane. You simply name it from the alkane. So in this case, your alkyl group is lack of one hydrogen at one point of the attachment. The alkyl group again is named from the alkane by simply replacing the A and E with YL. You have a suffix will be YL, using YL to replace A and E. For example, you have this substituent. How many carbons you have? You counted starting from this hyphen. This hyphen represents a group. So therefore it's 1, 2, 3, 4. 4 is your butane. You change A and E to YL. This one you call the butyl group. It's a group, it's a substituent. And then carbons, you have different types of carbons. Totally you have primary carbon, secondary carbon, tertiary carbon, and quaternary carbon. So primary carbon meaning your carbon, the carbon you are interested in, connected to one more other carbon. You call the primary carbon. That related group you call the primary alkyl group. If you have a carbon which connected to other two carbons, you call the secondary carbon. This group you call the secondary alkyl group. If you have a carbon connected to other 3 carbons, you call the tertiary carbon. This group called the tertiary alkyl group. If you have a carbon which connected to 4 other carbons, you call the quaternary carbon. This quaternary carbon does not have a group. So cause carbon at most you can connect it to other 4 carbons. These different classifications of your carbon atoms, totally 4 types. Your tertiary and secondary, tertiary groups may be commonly names and IUPAC name. Normally you use secondary and tertiary to name the groups. So the base group of these groups also from the longest continuous chain, which including the attachment of your carbon to form a substituent. You find that locant which is starting naming as your group. Like this group on your left hand side, how do you name it? First of all, find the group, find this dash. So carbon 1, 2, 3. You have 3 carbons, you have one of the substituents. Therefore, you name this group as your 1, 2, 3. If you 1, 2, 3 is propane, you call it propyl. In your propyl second carbon, you have a methyl. You call the 2-methyl propyl group. This group is also have a nickname, common name called isobutyl. You have 4 carbons totally. you call the isobutyl. This is a common name. Another group on your right hand side, you have your carbon, which is, this is a connecting attachment carbon, which followed by a hyphen, and then you have two carbons. In the carbon 1, you have 2 methyls. You call the 1,1 dimethyl ethyl. This 1, 2 carbon is called ethane. Ethane you convert it to ethyl. So 1,1 dimethyl ethyl group. This name, this compound, this group, you also have 4 carbons. So commonly you call it terbutyl. Terbutyl. That's how you are going to name it. So terbutyl or isobutyl or secondary butyl can be used in your IUPAC name can be used. For the highly branched alkane, so we are going to essentially name the compounds as what you did for the simple branched alkane. So you are going to find the longest continuous carbon chain again, and then you find the substituent which with a smaller locant. So in this case, this molecule, you name it as a, so let's see, 1, 2, 3, 4, all the way to 8. If it's 8, you call it octane. And you have number 3, you have methyl. Number 4, you have ethyl. If you have a methyl and an ethyl, how do you name these two different groups? You name the groups based on alphabetical order. So therefore, ethyl comes first, followed by methyl. Ethyl in number 4, you call the 4-ethyl-3-methyl octane. So that's how you name the compounds with highly branched one. Let's try one more. So this is one more compound. So you can label it in different way. You can label it as what I showed, one from your right hand side, counting back to the left. 1, 2, 3, 4, 5, 6, 7, 8. In this case, this methyl located in number 2. In the number 2 carbon, you have 2 methyl. Number 6, you have 2 methyl. Number 7, you have 1 methyl. You call 2, 2, 6, 6, 7 pentamethyl octane. If you name your carbon from the left hand side to the right, what's going to happen? You have 2, 2, 3, 3, 7, 7 pentamethyl octane. This molecule is not the right nomenclature. The reason is your locants will be larger. You choose the locants which have the less number. So that's how you are going to name the compounds. The second group of compounds, which is cycloalkane. Cycloalkane naming essentially similar to the non-branched alkane. So due to the formation of cycle, the molecule is going to lose 2 hydrogens. Therefore, cycloalkane contains a ring, at least 1 ring, which losing 2 hydrogens. The formula will be CnH2n. Before you have your alkane, so CnH2n plus 2. If you form a cycle, you minus 2. When you name it, you also find the longest carbon chain in the cycle, and then you put the cycle in front. Let's see the first one. 1, 2, 3. You have 3 carbons. You call the propane because you form a cycle compound. Cycle compound you call cyclopropane. Similar, this second molecule has 6 carbons in the chain, actually in the cycle. So you call it hexane. Because it's a cyclic compound, you call it cyclohexane. If you have substituted compounds, what you are going to do? Again, you are going to count the number of carbons. Always started from the substituted carbon. So this carbon is substituted. It's called 1, 2, 3, 4, 5. You have 5 carbons. You may call it pentane because you have cyclic compound. You call it cyclopentane. In your carbon 1, you have an ethyl group. You call this isocyclopentane. Number 1, the locant number 1, 1 dash, you can ignore it. So that's about the nomenclature of the substituted compounds. If you have multiple substituents, what you are going to do, you are going to find the smallest locant for the substituents. For example, this compound have 1, 2, 3, 4, 5, 6 carbon. You call the hexane. Methyl, methyl, 2 of them located in the number 1. And then number 3, you have methyl. That's how you are going to name it. You have 3 methyl, 3 ethyl, 1 dimethyl cyclohexane. Make sure your ethyl named first, although its locant is higher. And then 1 dimethyl, this 1 you can ignore it because the first substituent is by default on the number 1 carbon, so you can ignore it. But so 3 ethyl, 1 dimethyl cyclohexane. You are not going to start from number counting this carbon from the ethyl carbon, ethyl substituted carbon. The reason is you are going to have a 3,3 dimethyl. Eventually make it 1,1,3, 1,1,3, 1,3,3. This second one has a larger locant, so that's not preferred ones. If you have substituted cyclo compounds and you also have a branch, so which one you are going to use as a parent? In this case, you compare which one has the larger number of carbon. Let's see, this straight line one, the aliphatic one, 1, 2, 3, 4, 5 carbon. The cyclic one, 1, 2, 3, 4 carbon. So therefore, this number 4 carbon, that portion will be your substituents. Therefore, you call it this run is your substituents, and this 1, 2, 3, 4, 5 is your pentane, will be your parent. So the cyclobutane, 1, 2, 3, 4 is butane. Butane you change it to butyl. Cyclobutyl, which is located on the 3rd carbon, you call the 3-cyclobutylpentane. Again, when you name the compounds, make sure you find the longest carbon-carbon chain. If it's aliphatic, has the longer number of carbon, you use that as your parent name. Otherwise, if the cyclic compound has a larger number of carbon, that will be your major or parent naming. Followed by, we have some important information about the sources of alkane and cycloalkane. So there is several different groups. Carbon 1 to 4 usually is from refinery gases. Carbon 5 to 12 can be from lead, gasoline, and naphtha. And the carbon 12 to 15, 15 to 25 can be from your kerosene or gas oil. So this part of information will be further studied when you moving on to the higher level of chemistry classes. For all of this alkane and cycloalkane, you need to know their physical properties, particularly the boiling point. Generally speaking, you are going to compare the number of carbons. The larger the molecule is, the higher the boiling point is, the higher the associated melting point is. If you have branched and unbranched, the branched molecule usually has the lower boiling melting point. The reason is this kind of compounds, they have less London dispersion. So therefore, your intermolecular forces is another important factor to help you to identify the physical properties of the alkane, and including unbranched and branched and also cyclohexane.